Hello, and welcome to this tutorial on the MIPS3D software. MIPS3D is designed to run alongside MIPS Pro or MIPS View and show in 3D the inside surface of a tubular as imaged by a multi-finger caliper. The cursor position in the MIPS viewer is shown as a green dot in MIPS3D, allowing the user to investigate particular features. The color map in MIPS3D is normally the same as the VDL color map in the MIPS viewer, and this can be adjusted by editing the display layout. MIPS3D is normally started from the View menu in MIPS Pro or MIPS View. Select View, 3D View, and the 3D viewer will start in a separate window, showing the data and the depth range currently in the MIPS viewer. Firstly, I will show you how to move the image in MIPS3D. The image can be rotated about the horizontal X and Y axes by holding down the left-hand mouse in the viewer and moving the image in the required direction. It can be rotated about the Z pipe center axis by using the horizontal scroll bar. The horizontal axis movement can be made to continue by checking the continuous rotation button and then moving the image with the left-hand mouse. This can be stopped with a single left-hand mouse click. The 3D motion control form can be used to set up a controlled movement of the image if this is required, for example, for making a movie. This is accessed through View Motion. You can set the speed of rotation about any of the axes and then start the movement. The depth range shown in MIPS3D is normally controlled by the depth range in MIPS Pro or MIPS View. If the 2D viewer is zoomed in or zoomed out, or the depth range changed, MIPS3D will automatically update. It is also possible to pan the image of a fixed length of pipe through the depth range of the data. This is done using the MIPS3D motion control form. Open the form at MIPS3D View Motion. Set the pan speed to example to 0.5 units per second and click Start. The image will show a fixed length of pipe moving downwards through the data. To stop the motion, click Stop. The size of the whole image in MIPS3D is controlled using the Zoom slider bar. The relative size of the image in the radial direction is controlled by the XY scale slider bar. The relative length of the image is controlled using the Z scale slider bar. The actual radius to Z ratio is shown as a readout in the lower frame of the MIPS3D viewer. In order to calculate a grid image representing several feet of dense caliper data, a reduction algorithm is applied. In our example here, one grid node represents the maximum of 80 caliper samples. The reduction factor is normally calculated automatically, and for caliper data we recommend setting the reduction control to max to show the largest penetration features. If the depth range is adjusted in the 2D viewer, the reduction factor will be recalculated. The user can manually change the data reduction factor to change the density of the grid. Without a grid at all, for example, the data reduction factor can be set to 1. This shows all the caliper samples. To keep the reduction factor constant during changes of depth range, check the Fix Reduction control. The type of surface image is controlled from the MIPS3D Surfaces pull-down. MIPS3D supports two different styles of surface rendering: solid surface, where each reduced caliper sample is shown with a colour determined by the current colour map, and VDL, where the surface colour is interpolated between the samples. A grid joining neighbouring samples can be drawn over the coloured surface, or the image can be shown with just the grid. Sometimes a convenient way to see the inside pipe surface is the cutaway, which shows only half the pipe. You can look straight down the pipe by rotating the image so that the pipe axis points directly out of the screen. There is a shortcut icon for this at the top of the control panel. For normal views, it is best to set the perspective control to 30 degrees. For the fly-down view, you can see more of the pipe if the control is changed to 85. When returning to normal views, remember to set the perspective back to 30 again. The background colour of the whole display can be changed in the MIPS3D File Settings menu. MIPS3D can show a depth scale alongside the image and information next to each arm at the top of the pipe section. The visibility, content and colour of these labels is controlled from the View Annotation menu. Arm Display lets you set the source of information for the arm labels, choosing from twice radii values, arm number, arm azimuth or no label at all. The depth scale can be shown at the top, bottom or intermediate positions. The colour of the arm labels, depth scale and VDL colour maps can be selected from standard colour palettes. A JPEG image of the MIPS3D display can be captured from File, Save JPEG. This will normally be saved in the Project Images folder. If you wish to capture a movie of a 3D animation, this is done using the Record AVI Movie form accessed from File, Record Movie. When making movies, it is usually best to practice the movements before hitting the record button, and if possible to control the animation using the motion control form accessed from View Motion. Note that the AVI files can be quite large if the movie is long. MIPS3D can also show an outside diameter profile read from the pipe nominal OD or calculated from thickness measurements. The visibility of the OD cylinder is switched on and off from MIPS3D Surfaces Show OD. The details are controlled from the OD Display Manager accessed from Surfaces OD Settings. The OD can be defined in three ways: average OD, read from an auxiliary curve; average thickness, read from a selected auxiliary curve and added to the average arm value; or an array of OD curves read from a separate .mip1 data file. More details on displaying OD cylinders can be found in the MIPS3D manual. In order to preserve a MIPS Pro and MIPS3D scene so it can be reopened later, simply save a context file using MIPS Pro, File, Save Context As. If MIPS3D is open, the details of the 3D display will also be saved. When the context file is opened again in MIPS Pro or MIPS View, MIPS3D will also open and show the same scene. That is the end of this MIPS3D tutorial. More information can be found about the software in the manual supplied with the package.